I want to take a few minutes to talk about the terminology that I'll use throughout the production in regards to the frame itself. So starting at the bottom here, we have the grade. Now grade is basically the ground in which the structure is actually sitting. Now, this is not the finished grade right now. The finished grade will actually come up to about 6 inches away from the wood and will slope away from the building. The foundation in this case is a monolithic slab on grade, so you may hear me talk about the slab. That's going to be the actual concrete surface itself. The toe-ups, you can see here, these are our exterior toe-ups. This is also what would be called in conventional construction would be the sill or the sole plate. This is basically what gets the posts up off of the ground. And as you can see in this case, they're pressure treated, whereas the posts are not pressure treated. If we didn't have the separation of the toe-ups from the posts, we would have to make sure that the posts were pressure treated because they would be in contact with the slab. This is a corner post assembly. You can see that it's a 4x4 with a 2x4 next to it, so it's slightly wider than a standard 4x4 post, which is what we use in the structure itself, moving through the structure. The door rough opening, that's this area right here. That's the opening for the door. Now the door rough opening is made of a trimmer stud, or 2 trimmer studs, which is right in contact with the door jamb, the inner stud. And the outer stud is called the king stud. Now the trimmer stud goes up and stops. You can see well here that it terminates right up against the header. Now there will be a box beam put in place here, and I'll talk about that in a minute. But for now, this is the header that moves across above the door, and you can see where the trimmer stops on the bottom of the header, whereas the king stud extends beyond all the way up to the top plate. The top plate you can see here is a 2x4, and on top of that there's a beam. So I often refer to this as the top plate beam assembly. The top plate is a simple laid flat 2x4, and up above that in this case we have a 4x6 as our beam. Now let's jump over to the window rough opening. You can see here this is where a window will go. And in this case we have again trimmer studs. The trimmers come up from the bottom. They come to our double sill. The trimmer continues above and goes right up to the top plate in this case. Again, that's where our box beam will take off from. That's a little different than what you see in a standard straw bale construction process where you'd have a box beam set into this window opening and then the top plate and beam assembly would be considerably higher. Again, this is a smaller structure, so we're dealing with a lower ceiling and therefore our windows are terminating right at the bottom of the top plate beam assembly. Moving up, you can see the rafters. These are the rafters back in here. That's what's supporting our roof, or what's actually making up our roof. These are called the rafter tails. Those are the parts that stick out from outside of the structure of the rafter. In between the rafter tails, we have a vented bird block. That's another piece of material that basically blocks out so that we can't get insects and birds flying into our roof. And we put vents in it to allow ventilation to move through. The bird's mouth is different than the bird blocking. The bird's mouth is this cut in the rafter. So you can see the shape right here. That shape is called a bird's mouth. That's what keeps the rafter sitting so that it's at the perfect angle for our roof. Lookouts or outriggers, you can see all the way back here, coming all the way through. They cut through the rafter and come out to support this exterior rafter. These 3 pieces, 1, 2, and 3 that you can see there, are lookouts or outriggers. Now their job is to support what's called either the fly rafter or the barge. And that's the rafter that hangs outside of the structure. In this case, we have a double barge or a double fly rafter. You can see there's one layer of barge rafter or fly right here, and on top of that there's a secondary layer that sits on top of it. That secondary layer, you can see at the corner, is joined up with what's called the fascia, and this long piece that goes all the way down the face and hides the ends of the rafter tails is called the fascia. On top of all of that is our roof sheathing. You can just see it sticking out here a little bit. That's our plywood that is on top of the roof and basically gives us our roof surface. We also have cripple studs going back to the bottom here. This small stud right here is a cripple stud, and this small stud right here underneath the ridge is also a cripple stud. Cripple studs are smaller studs that do not make it from the bottom all the way up to the top. They're stunted. They stop right in between. So this one goes from the toe up. It goes up to the bottom of this box set here. Now this box is designed for a specific reason. This box is the backing to a window seat because our windows stop here, but our bales stop down below this box. So we had to find some way to bridge that gap and make sure that it was insulated and properly set up for backing our plaster. So this section here is designed to hold the plaster and insulate the wall. It's framed like a standard partition wall, or like i.e. an interior wall, or any kind of wall. This is set up with a 2-foot center for the studs going across, and then it has plywood on both sides. You get a good shot here at the top of that of the double sill of this other window opening on the far side of the wall. Now you might notice with that, the bottom of that sill is a 2x4, and the top of that sill is a 2x6. That's difficult to see on this other window that I started with, but it's more apparent if you look over here. 2x4 on the bottom, 2x6 on top. Now moving into the structure, you can see running down the center where the rafters connect is the ridge. This is a ridge beam because it's supported on either end by this cripple stud and ultimately transferring that load down through a post, down into the foundation. So this is a ridge beam. There's also ridge boards. A ridge board would not have the support here on the end. It would basically just be floating between the rafters. In order to do that, you would have to have ceiling joists horizontally across the room, or what's called a collar tie, which would be a piece of wood nailed about here, all the way across to the other side of the rafter at a horizontal line, a level line. The job of either the ceiling joist or the collar beam is to stop the roof from collapsing under any loads put on it from the top. You can see again here the lookouts 1, 2, and 3 holding our double barge rafter in place. And here's another shot at that. You can see here the lookouts coming all the way through. They extend back to this rafter here. They come out, they notch through this rafter, they notch through this rafter, and they extend all the way out to catch the barge or fly rafter. It's another good shot of the top plate beam assembly, the cripple post, and our ridge all the way down the structure. And you can see on the very end here, each rafter has our hurricane clips in place. Now here's a good example of the window frame. You can see at the top we have the box beam. This is designed specifically to hold the bales above the window opening so that they can span over the top. Now in this particular case, we have a stud framed wall. So here you have a 2x6 stud, and a great example within the window of the king stud, a trimmer stud, a double sill, a cripple stud, and the same assembly on the other side, the trimmer and the king. So those are basically all of the terms that I'll be using throughout this production. If you come across a term that you don't understand, I'm not using anything terribly fancy, so you can probably look it up online and figure out exactly what I mean. Or hopefully throughout the production, I'll be clear enough as to what I'm actually doing when I use the term that you'll be able to understand where we're at.